Hello and welcome to today's video. Today's video is for Advanced Geometry, Chapter 4, Section 5, Isosceles and Equilateral Triangles. Okay, so we start out with a diagram to show you some parts of an isosceles triangle. So from before, an isosceles triangle has at least two congruent sides. And if we take those two congruent sides, we can call those the legs of the isosceles triangle. And then between the two legs, we have the vertex angle. And then the two angles that are not the vertex angle are called the base angles. We want to be careful. We don't want to call them the bottom angles because the isosceles triangle could be turned on its side. It could be flipped upside down. So the vertex angle is between the two legs, and the other two angles are called the base angles. Okay. So the first thing we have is an isosceles triangle theorem. If two sides of a triangle are congruent, then the angles opposite those sides are congruent. So if I'm given that CA is congruent to CB, I can use this theorem to say that angle A is congruent to angle B. Okay. So if you take a look at the sides and then you take a look at the angles that are across from them, otherwise known as the base angles, then they are going to be congruent. One thing to notice is with the isosceles triangle theorem is if you read the theorem, it never says it's an isosceles triangle. It says if two sides of a triangle are congruent, then the angles opposite those sides are congruent. So if you use this theorem in a proof, which you will, you don't actually have to state that it's an isosceles triangle. Okay. And then the converse of the isosceles triangle theorem says if two angles of a triangle are congruent, then the sides opposite those angles are congruent. So if I'm given that angle A is congruent to angle B, then I can say that side CB is congruent to side CA. And again, the converse of the isosceles triangle theorem, again, doesn't actually, you can use it to prove that a triangle is isosceles, but you'd have to first use the converse of isosceles triangle theorem to prove that the sides are congruent, and then you can use definition of an isosceles triangle to say that it's an isosceles triangle. And then the last one is the only one that actually has anything in it about isosceles triangle. And this one says the bisector of the vertex angle of an isosceles triangle is the perpendicular bisector. Oh, I'll change that. Bisector of the base. So if we're given that we have an isosceles triangle and we bisect the vertex angle, then we can say that that bisector of the vertex angle is the perpendicular bisector of the base. So what this one can end with is that CD is the perpendicular bisector of AB. This one I like to call the isosceles triangle angle bisector theorem. And we are going to prove the isosceles triangle theorem, and so we'll do that one in class. If we want to find the value of y for this one, it looks like I have an isosceles triangle and I've bisected the vertex angle. So this is the perpendicular bisector of the base. So what I can do is I can say, well, this is 63 degrees. I don't actually need that it's a perpendicular bisector because all the angles add up to be 180 degrees. So I can take 180 and subtract 63 twice, or 126, and I get 54 degrees. A corollary is a statement that follows immediately from a theorem. In other words, it's pointless to have a new theorem because it really is just one more step to make the next leap. So we have a couple corollaries to the theorems we've learned. Okay. So if a triangle is equilateral, then the triangle is equiangular. So this one is based on the fact that, well, if xy is congruent to yz, then the two base angles here are congruent. But we also know that yz is congruent to xz, and so that means that these two base angles are congruent. And if you take a look, we have transitive real quick. So angle Z is congruent to angle X, and angle X is congruent to angle Y, so that means that they're all congruent. And then using the converse of the isosceles triangle theorem, we can say that if a triangle is equiangular, then it is equilateral. So for basically the same reason, if X is congruent to Z, then that means that these two sides are congruent. And then all we have to do is use two different angles. So if angle X is congruent to angle Y, well then these two are congruent, and then we've got transitive real quick again. And that is it for today's notes. Thank you for watching. Have a great day. Take care.